Okay, now that we're armed with the knowledge of how higher degree exponents work, we're going to resume factoring, and starting with a classic formula that we've seen many times. A squared minus b squared equals a plus b times a minus b. And we can clearly see why this works, again, because if we were to simplify it out from the right side, this is a squared minus ab plus ab minus b squared, and the minus ab and plus ab would cancel out, leaving us with this. So if we have a problem like this, and again we've done something like this before, this is the a squared term and this is the b squared term. So to find a and b, we just take the square root of both terms. Square root of 4x squared would be, square root of 4 is 2, square root of x squared is x, so 2x plus square root of 9 is 3, square root of y squared is y, 2x plus 3y, so that's a plus b, and a minus b would be 2x minus 3y, and we're multiplying those two terms together. Now we're just going to do the same thing, except now we have exponents that are higher than 2 involved. So what is the square root of 4x to the 4th to find a? Well, square root of 4 is still 2, but the square root of x to the 4th. So what term times itself will give us x to the 4th? Well, remember, when we're multiplying terms together with the same base, we add the exponents. So think about this. If we're adding two exponents together that are the same to get 4, then we want half of 4. So 2x squared, and that is because x squared times x squared, we add these two together to get x to the 4th. So the square root of anything to the 4th is to the 2, because it's half. And then square root of 9y squared, we did that here, it's 3y. Okay, let's keep going with these higher exponents. So again, as we showed here, because we're adding two exponents together that are the same, since it's squared, we're just taking half of this exponent when we take the square root of the whole term. So this is going to be 4x to half of 6 is 3, plus 5y to the half of that is 4. And let's do one more like this. So square root of 1/4 x to the 10th. Square root of 1/4 is 1/2, because 1/2 squared is 1/4. X to the 10th, half of 10 is 5, so x to the 5th. Square root of 121 is 11, so plus 11 times 1/2 x to the 5th minus 11. Okay. Not going to spend too much time on that since we have done this formula before in previous videos. So let's move on to something new. Well, this is pretty basic. X squared plus x, we know we can factor out an x. And x times what equals x squared? X times x equals x squared. X times what equals x? X times 1. So we factor this to x times x plus 1. But now what if we have something where we have x's of higher terms, 3 and 2? Well, instead of just factoring out an x, now we can factor out an x squared, since we have x squared or higher in both. So if we factor out an x squared, and actually there's something else we can factor out too. we can factor out from the x. We can also factor out from these coefficients. What can we factor out of 2 and 4? We can factor out a 2. So we're factoring out a 2 and an x. So we're factoring out 2x, factoring out an x squared. So we're factoring out 2x squared from both of these. So now, once we figure out what we're factoring out, we just have to see 2x squared times what equals 2x cubed. Well, the only thing missing is the x here is one higher. So 2x squared times x is 2x cubed. And then 2x squared times what is 4x squared? Well, the only thing that's different here is 4 is twice 2. So x plus 2. And if you simplify this back out, you'll see we do indeed have 2x cubed plus 4x squared. So this is the kind of factoring that we're going to be doing a lot from here on out, where we factor out several things at once with these higher degree exponents. Okay, so in this one, we have x cubed here, but only an x here. So the only x we can factor out is just 1x. But we can factor out a constant. 12 and 27 are both divisible by 3, yes. So we can factor out a 3 and an x. 3x times what equals 12x cubed. To get from 3 to 12, we multiply by 4. To get from x to x cubed, we multiply by x squared. To get from 3x to negative 27x, we multiply by negative 9. And there we go. In this one, we start by doing the same thing. We have a 4 here and a large number 324 here. So the first thing we can say is, can we divide it by the maximum amount that it could be divided by in this problem, which would be 4? And yes, we can. 324 is divisible by 4. So we're factoring out a 4. And then we have x to the 6th and x squared. So we can take an x squared out of both. 4x squared, the only thing we need to get back to 4x to the 6th is x to the 4th. And to get back to negative 324, we already have the x squared. To get from 4 to negative 324, we multiply by negative 81. But we are not done with this problem just yet, because now this term inside of here is factorable using the formula that we just did previously. This is a squared minus b squared, because both of these terms, we can easily take the square root of that. Of each one. You should be able to recognize that. And when it's a minus here, we can use that formula to factor it. So this is going to be 4x squared times square root of this is x squared plus square root of this is 9 times x squared minus 9. And in fact, we can even go further, because we can apply that formula one more time to x squared minus 9. Not this x squared plus 9, because it doesn't work with a plus, only with the minus. So this will be 4x squared times x squared plus 9. And now we factor this to x plus 3, take the square root of both, times x minus 3. Okay, so we were able to factor that one 3 times. So once we start getting to things like graphing, it's going to be very helpful to factor as much as possible. Always keep factoring and simplify all the way. So in this one, now that we have x here and x and y over here. So it might not look like there's anything we can factor, but remember that each of these is a separate term. So we can factor out an x squared out of here, even though there's also a y squared. So we can factor out an x squared out of both of these. Nothing we can factor out of these two numbers, 49 and 64, are not divisible by anything. But you should be thinking of something else we can do to them that we're not going to do quite yet. So first we'll just factor out an x squared. to get it so there's only x's here and only y's here. So x to the 8th divided by x squared is x to the 6th. And we factored out the x squared, so we only have y squared here now. And what you should have noticed is that 49 and 64 are perfect squares, meaning we can take the square root of them and get whole numbers. This minus sign is here as well, so we have all the tools that we need in order to apply the a squared minus b squared formula. So we have our x squared on the outside, and now we take the square root of both of these. This will be 7x cubed, and this will be 8y. And then 7x cubed minus 8y. Okay, that is part 2 of our factoring in this video. Now let's move on to our last formula. This one is how to factor a cubed plus b cubed. So two terms that are being cubed. And the formula is a plus b times a squared minus ab plus b squared. Not that long of a formula. Good to commit this one to memory. After a little bit of practice, you shouldn't have too much trouble doing that. So we'll start with a pretty easy example. X cubed plus 8. The first thing you want to do is find the cube root of both of these. And that's what's pretty easy here. Cube root of x cubed, what times itself will be x cubed? Well, it's just x. X times x times x is x cubed. And the cube root of 8 is 2. So this will be a plus b is x plus 2 times a squared is x squared minus ab. A is x and b is 2, so minus 2x plus b squared, so plus 2 squared plus 4. There we go. Now one more thing we want to add here is that if you have a cubed minus b cubed, then all you do is flip this sign. That becomes a minus b, and then you'll have a squared plus ab. So again, in case you don't remember, all this double sign means is that if you have plus here, you have plus there, minus there. If you have minus there, you just go along the bottom. Minus there, plus there. All right, going to get a little trickier when we have larger numbers here. What is the cube root of 27x cubed? That's just going to be cube root of 27 is 3. Cube root of x cubed is x. So 3x plus cube root of 64, minus here. Since we have a minus there, we go along the bottom here. Minus cube root of 64 is 4 times 3x squared, so 9x squared plus ab. Remember that the sign flips since we have the minus there again. So plus a times b plus 3x times 4. So plus 12x. And then plus b squared plus 4 squared plus 16. All right, now for something like this, you look at it and say, okay, we got to take the cube root of both of these terms. Now, how do we take the cube root of 8x? Well, there actually is a way. It involves fractional exponents, which we haven't gotten into yet. So instead of worrying about that, just do the easy thing and notice that you have an x in both of them and factor that out first. Always do standard factoring out of terms before anything else. So we factor out an x, we're left with 8. And now over here we factor out this 4 reduces by 1, so 125x cubed. And now that we have this, we can apply this formula. We have a cubed minus b cubed. So this is going to be x on the outside times a minus b. So 2 minus 5x. A squared plus ab plus b squared. So 4 plus 2 times 5x, 4 plus 10x plus 5x squared plus 25 times x squared. And you know what? If we want to make this a little neater and write it out the way it's normally written, you want to have it in, this is sort of alphabetical order for math, where you have the highest degree terms out in front and then going in descending order. So we're going to have x here, but we want to have this 5x at the front of this term. It's also usually looks neater if the negatives are not right after the parentheses. So what we're going to do is factor out a negative from this whole term, so that 2 minus 5x, or negative 5x plus 2, will switch to 5x minus 2. The negative will go in front of the whole thing, since everything is just being multiplied together. It doesn't matter where it goes. So we'll put it in front of the whole thing. So we actually have negative x now. Negative x. And now 2 minus 5x changes to 5x minus 2. And then over here, we're just going to rearrange the terms. Okay, that would be the final simplified form. Okay, and with that problem, we're going to end this video and continue with more higher degree factoring next time.